Hey students of Seneca, thanks for joining me, Jono, on this A-level chemistry revision episode. Today we're going to be talking about isotopes and mass numbers, okay? Make sure you're up to speed on the fundamental subatomic particles you need to know for your A-level exam. They're covered in a previous episode because we're going to be building on that knowledge today. So let's dive in. Mass number and proton number. Those are two key metrics that you need to be very familiar with. The mass number of an atom is the number of protons and the number of neutrons, and it's often represented by the symbol A. Now, what's the proton number? Unsurprisingly, the proton number tells you the number of protons in the nucleus of an atom, okay? And it's often given the symbol Z. So, what was the mass number? It's the number of protons plus the number of neutrons. Okay, now we're going to talk about some ion formation. So, we've talked about protons, we've talked about neutrons. Seems like something's missing maybe. Well, the thing that's missing, electrons, okay? So atoms have electrons that can be added or removed to generate ions. A positive ion has more protons than electrons because electrons have a negative charge. And to generate positive ions, we remove electrons from a neutral atom, and this produces a positive cation. Okay, or cation, I don't know. I say cation because I really like cats. And these terms all come from electrochemistry because cations are the positive ions that go to the cathode. Cathode is the negative electrode, okay? So, how do we form negative ions? Well, honey, we were just taking electrons away. Now we've got to give something back. So if we add electrons to a neutral atom, we form a negative ion and we call that an anion. Okay, so cations, positive, anions, negative. So how do we calculate that charge? Basically, we have the number of protons and we subtract the number of electrons, and that gives us the overall charge. Okay, now the overall charge of any chemical substance will be 0. So cations will always be accompanied by anions in solids or solutions. They get lonely, they just want like a cute little friend, okay? So anions and cations live together in blissful harmony. Okay, so that's the principle of electro neutrality, which sounds super fancy, but basically it just means that cations will always be accompanied by anions. Now, let's go over some facts about cations. Were they positive or negative? So they are positive, and they are always accompanied by anions. They get lonely, they don't want to be by themselves. And do they have more neutrons than electrons? Nope, they have more protons than electrons, okay? Now, do you remember those definitions from the start of the episode? Proton number, that's the number of protons in the atom nucleus. Mass number, total amount of protons and neutrons. Okay, now we're going to switch things up a bit and talk about isotopes. Now, isotopes are atoms of the same element that have the same proton number, but a different neutron number, okay? This means that atoms have a different number of neutrons. Makes sense, right? So important examples of different isotopes are radioactive 40 potassium and the stable 39 potassium. So 40K or 40 potassium is the reasons why bananas are slightly radioactive. Ooh, okay? So the effects of this on chemistry are basically important to know. So, chemistry is about largely electrostatic interactions between nuclei and electrons. So, neutrons have no electric charge, and so changing the mass number of a species rarely affects its chemistry. So that means it can be chemically very difficult to distinguish isotopes. So, isotopes, different number of neutrons, but they have very similar chemistry to each other. Do you remember the charge of a neutron? It's 0, okay? So, do we remember how we form ions? Do we remove protons? Maybe we add protons? It's all about electrons when we form ions. We remove electrons from atoms. And what's the key principle of isotopes? They have the same proton number, but a different mass number. So that means they've got the same amount of protons, but a different number of neutrons. Okay, that brings us to the end of this episode. I hope it was useful. Make sure you review your notes on this and consolidate your learning to get you up to speed for your A-level exam. Keep up with all your hard work and good luck.